This is something that you should not do when dealing with the equal sign. I've seen people do this. Suppose you have a list, right, where the n is the position of the list. First position, second position, third, fourth, fifth, and so on. Alright, now let me do it vertically because this is how I've seen it done. So you have 1, 2, 3, 4. Then they've put an equal sign. Alright, this is so wrong. If you get into higher maths, sequence, now they tend to use something like A of n. It just means the value in the sequence. Any particular, you know, the first one will be A1, second one will be A2, third one A3, and so on. So these are the values in the sequence. They said 1 is equals to 2. No, 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 no. 1 no way has the value of 2. 2 no way has the value of 4. This is what it means. The equals means that what is on this side of it here, whatever these values are, have exactly the same overall value of what's on that side. This here is wrong. Another thing I see is people do something, you know, they do a set of working out, then the next line they put equals, the next working out, equals, the next working out, equals, next working out. Don't do that. That is so bad practice. Okay? Right, that's dealt with the don'ts. Now, you would have in your earlier teachings come across number machines where you have a box, you put some value into it and you get some value out, for example 2, and you might get 5. Well, that is the answer. So another way of doing it is that suppose we don't know what that value is. We know it's there, there's a value, but we don't know what it's worth, and we get the answer 5. Well, this is where we're going to be starting using equations. The equation is the process that we apply to the unknown value to give us the answer, and we need to work backwards to find out what the actual value of x is. It could be A is an unknown, B is an unknown, C is an unknown, X is an unknown. It doesn't matter. It is a unknown. For addition and subtraction, let me draw a line down here. And over here we're going to be looking at multiplication and division. Unknown. Now I'm going to use the letter B just because I don't want to use the letter X. Plus, say, 4. And when you apply that process of plus 4 to whatever value B is, it will give us an answer. Now I'm going to set the answer as 15. As soon as I do that, it fixes the value of that. But mathematically we need the process of having that on its own. We want to find B equals. In other words, we want to find the value of B. So we B on its own on the left and some numbers on the right. Let's get rid of that. Okay, so we want b on its own. That means we have to get rid of the 4. Now for addition and subtraction, we change what we don't want into 0, because b plus 0 does not change the value of b. This is what they call first principles. You would have been shown the shortcut method. Okay, so I need to turn that into 0. Well, to do that, I need to remove it. And mathematically, remove is subtract. So we have b plus 4 as over here. Now I'm going to change it. I'm going to remove the 4. Now, because I've applied that action on the left, I must apply the same action on the right. There's the 15. Now I apply that action on the right, so minus 4. This here now becomes 0. So we have b plus 0 equals 15 minus 4 is 11. So in fact we have found the value of b is equal to 11. So we substitute 11 in there, right? If we put 11 in here, 11 plus 4 is 15. That's with addition. What we did is we changed that to 0. And notice the 4 ended up on the other side. But the sign here, the operation, was the reverse operation of that. That's what you would have been shown. You would have been shown this. We had b plus 4 as the starting point equals 15. Take the 4 over the other side, so end up with b equals, there's the 15. Change the sign, do the reverse, negative, or subtract 4. In an exam, use the shortcut method. You apply the reverse operation. I showed you that this indeed is what happens. I've shown you the first principle upon which the shortcut is based. So that is dealing with plus 4. What if we had minus 4? b minus 4 is equal to 15. Okay, let's use the first principle. We change that to 0. So we have b minus 4. Now if I want to change that to 0, I put plus 4. There's the 15. Now because I put plus 4 on the left, I have to put plus 4 on the right. This becomes 0, so we end up with b equals 15 plus 4 is 19. The shortcut, you take the 4 over to the other side. There's the b, there's the equals. You take the 4 over the other side. There's the 15. We've now moved the 4. Now look at the sign. Sign is subtract, so we add when it's on the right. First principles, shortcut. That's dealt with addition and subtraction. Multiplication and division. I had b plus 4. I'm going to do 4 times b. No, we don't write it like that. We just write 4b equals 15. We want b on its own, so we need to get rid of the 4. Look, that is multiply. So if I have 4 times b, I divide by 4 equals, now because I've divided there on the left, I need to divide on the right as well. Rewrite this, b times 4 divided by 4 equals 15 divided by 4. 4 divided by 4, that becomes 1. So we have b times 1 equals 15 divided by 4. Well, that won't work as an exact value, so I'm going to write it like that. See, I changed it to 1. For multiply and division, what you want to move to the other side, change it to 1. Shortcut method. 4b equals 15. Multiply there, so we have b equals 15 over 4. Done. Shortcut method is faster. In an exam, use the shortcut method. Now that is multiply. What happens with divide? Now previously we had 4 times b. Now we're going to be looking at b divided by 4, right, which can be written as b over 4 equals 15. What the b on its own? Now I can write that as b times 1 over 4 equals 15. Nothing's changed. It's still the same. Now I want to change that into 1 because 1 times b gives you just b on its own. So if I go b times 1 over 4 and I multiply that side by 4 equals, there's the 15. Because I multiplied the left by 4, I multiplied the right by 4. This becomes b times 4 over 4, which equals 15 times 4. This is the same as 1 equals 15 times 4. Well, 2 15s is 30, so that's 60. So b is equal to 60. Okay, that's the first principles. For multiply or divide, you change it to 1. What about if this was a shortcut? Okay, we have b over 4 equals, what was it, 15 did I say? Okay, well, using my own words, totally non-mathematical, the 4 is downstairs. b equals 15. Now put the 4 upstairs, so instead of there, as divide by, it becomes multiplied by 4. Right, so b is equal, 2 15s are 30, 2 30s are 60, done. That's the shortcut, which is what you would have been shown in school. First principles. For multiply and divide, change it to 1. That is so important. For addition and subtraction, change it to 0. And magically they will end up on the other side of the equal sign. Oh, there's one I nearly forgot to show you. Suppose we had it this way, look. 2 over b. So in fact we were dividing by b equals 15. How do we get b on its own? Well, think for a moment, just to make it simpler. People don't write it this way. These numbers, 1, 2, 3, 4. Really, it is 1 over 1, 2 over 1, 3 over 1, 4 over 1. Because it is the same format as fractions. This is what I call the size indicator, denominator. That is the count. A quarter, or suppose we had 3 quarters. That's the size indicator. That tells me how many of these is needed to make a complete 1. This is saying you only need 1 of what you're counting to make a complete 1. This one is saying you need 4 of what you're counting to make a complete 1. You see, they follow the same rules. So I'm going to put 1 over there. Let me just get rid of this. That idea of counting numbers being over 1 is quite important, because it can remove confusion. Now, it is perfectly correct. I know they say cross multiply and all that lot to end up with b on the top. Just turn the things upside down. So b over 2 is equal to 1 over 15. Yep, you can do that. That is absolutely correct. Notice I don't put an equals there. This is where the equals should be. Now, I need to change that into 1. Shortcut method, it's downstairs. Put it upstairs over there. So we end up with b is equal to 2 15ths. Turn the damn things upside down. It's quite straightforward, really. It really is. If you're not sure that this is the case, let me a quarter, convert to a decimal, 0.25. Technically, I should write that over 1, but people don't. Okay, you've done that. Turn everything upside down. 4 over 1 equals 1 over 0.25. Divide that into that and you get 4. No, 4 over 1 equals 1 over 0.25. Divide the bottom by 0.25. Divide the top by 0.25. And we end up with 4 over 1 equals, divide that into that, we get 4. Divide that into that, we get 1. This is a particular area in the topic that people really need to think about a lot. Watch this a few times. Try it out with yourself. Use a calculator to check your answers and see if you're right. If you're in doubt, use small value numbers to see how the system works.